Hello everyone, welcome back to a new video. In our last video, we learned that artificial intelligence is the idea of making computers think and act smartly like humans do. We talked about how AI can recognize your face, understand your voice, translate languages, and even beat world champions at chess. Pretty amazing, right? But today, one big question is waiting for you. How does AI actually get so smart? What is the engine running underneath all of that intelligence? The answer is machine learning. Machine learning is not separate from AI. It's actually a part of AI. Think of it this way. Artificial intelligence is the big idea, making machines smart. Machine learning is one of the most powerful ways to achieve that. So if AI is the destination, machine learning is one of the best roads to get there. In older AI programs, humans wrote every single rule by hand. If the user says this, do that. But machine learning flipped the script. Instead of writing all the rules ourselves, we give the computer data and let it figure out the rules on its own. That is the superpower of machine learning. So what exactly is machine learning? Let's make it super simple. Imagine you want to teach a little kid what a cat looks like. You don't write them a rule book. You just show them photo after photo that this is a cat. And after seeing hundreds of examples, the kid's brain figures out the pattern all by itself and can now spot a cat in any photo, even ones they have never seen before. So machine learning works exactly the same way. We have a computer program called a model. We feed it thousands of labeled examples. It finds hidden patterns, and then it can make smart predictions on brand new data it has never seen. That's it. That is machine learning. Teaching computers to learn from examples just like you learn from experiences. Now, for a machine learning to learn, it needs something very important. Data. Specifically, training data. Think of training data as the machine's textbook. A good textbook means a well-prepared student. A bad textbook or too few pages and the student will struggle. Training data is simply a large collection of examples we give the machine to study. If we want it to tell apart dogs and cats, we give it thousands of dog photos and thousands of cat photos. And the better the quality of those examples, the smarter the model becomes. There's a famous rule in computing: garbage in, garbage out. Feed the machine bad data, you get bad results. Now when we give examples to the machine, we attach a name tag to each one. This is called a label. So every dog photo gets a label that says dog, and every cat photo gets a label that says cat. Now the machine knows what it's actually seeing, and once the model has seen enough labeled example, it starts to notice patterns. Patterns are the secret features that separate one thing from another. For example, cats have pointy ears and vertical slit pupils, and dogs have rounded, often floppier ears. The machine doesn't need us to point this out. It finds these patterns itself just by studying the data. That's the magic. These patterns are what the model stores and uses later when it sees a brand new image it has never encountered before. Alright, let's actually build a machine learning model right now. We will use a free tool made by Google called Teachable Machine. No coding needed, just a browser, some image files, and your brain. First, open your browser. Whatever you use, Chrome, Edge, anything. In the address bar, type teachablemachine.withgoogle.com and press enter. You will land on the Teachable Machine homepage. Click the big button that says Get Started. From this page, click on Image Project. Then click Standard Image Model. A new project will open up. You will see two boxes, Class 1 and Class 2. Click the pencil icon on Class 1 and rename it Cat. And click the pencil icon on Class 2 and rename it to Dog. These are the two things your model will learn to tell apart. Now here comes the most important part, adding training data. Remember, this is the collection of example images the machine will learn from. The more images you add and the more varied they are, the smarter your model will be. Under the cat class, click Upload. Select at least 10 to 20 cat images from your computer. You can download these images from internet. Use images with different cats, different colors, sizes, angles, backgrounds. Why? Because variety teaches the model what all cats look like, not just one. Now do the same under the dog class. Click Upload, select at least 10 to 20 dog images. Again, use variety, different breeds, different poses, different lighting. After adding the training data, click the blue button, Train Model. The computer will now scan every images, find patterns, and build your personal machine learning model. Wait for it to finish. You will see a progress bar. And done. The model has finished training. Now let's see it in action. On the right side, you will see the preview panel appear. Click Upload in the preview panel and pick a cat or dog image that was not in your training data, a brand new one. Watch what happens. See that? On the right side, you can see the output. It says cat. That percentage is the confidence score. Let me explain that quickly. A confidence score is the model telling you how sure it is about its answer. 100% means it found very strong cat-like patterns in the image. Pointy ears, whiskier shapes, the face structure, it's very confident. Now let's try a dog image. Watch how the bar shifts. The model switched its answer because the patterns it saw this time matched dogs more closely. And that's it. You just build a real machine learning model from scratch using training data, labels, and pattern recognition. And that's all for today. Today we learned that machine learning is the most powerful method inside AI. It's how AI actually gets its intelligence. In our next video, we will go one level deeper and understand how sound model works and how computer actually finds pattern in sound. Until then, try training your own model at home with different objects. The more you experiment, the more you learn. See you in the next one.